Lesson 2.3. Up till now, we've looked at how to evaluate algebraic expressions and how to write algebraic expressions, but now we're going to shift gears a little bit. When we had algebraic expressions, we were given a value for x or for g or whatever our variable was, but now we're going to look at what happens when we don't know what that variable is equal to, and we are going to find the value. So, we are going to be solving equations. Now, an equation means that it has an equal sign in it. An algebraic expression would look like this. This is an algebraic expression. An equation would look like this, where there's an equal to and something on the other side, whereas the expression is just this, no equal sign. So sometimes our variable will be part of an equation. To solve for a variable, we're going to use inverse operations. And the way we're going to think of inverse operations is doing the opposite, or what undoes the other. So if we have addition happening, subtraction undoes addition. If we're dealing with multiplication, that's what we'll look at next time, but multiplication undoes division, etc. And we want to think of this like a scale. If we have a scale, with two sides, we want it to be evenly balanced. That's my best draw on a scale. If I add 2 to this side, it'll start to weigh down this side unless I add 2 to this side. Similarly, if I subtract 2, I also need to subtract 2 to the other side. What we do to one side, we do to the other. And this phrase is going to be very, very important for this whole unit. What we do to one side, we do to the other. Thinking about keeping that scale nice and balanced. So, we are given an equation to solve, and we want to find what is the value of x. So the first thing that I'm always going to do is draw a line straight down through the equal sign, and this shows me the division between my two sides. I have my left side, and I have my right side. So I'm trying to get x by itself. And so I'm saying, okay, what is happening with this? It has x and then minus 9. So I want to think about what's going to undo that, and in this case it would be adding 9 to both sides. Now if I do negative 9 plus 9, that's going to equal 0, and I'm going to get x equals 21. Now it's really good to get in the habit of checking your work. To check our work, I'm going to take this value of 21, and I'm going to plug it in for x. And that gives me 21 minus 9 equals 12. Well, if I do 21 minus 9, I get 12. So now I have 12 on both sides of the equal sign. So this is a true statement that 12 is equal to 12. And this is my final answer. X equals 21. Drawing my line. I've got x and then minus 17. I need to do the opposite operation. Since it's minus right now, the opposite would be to do plus. So I'm going to do plus 17 on both sides. Negative 17 plus 17, those cancel out. And I'm left with x equals, and now I have negative 5 plus 17. Since the signs are different, I've got a negative and a positive. I'm going to subtract the number. 17 minus 5, which is 12. And then keep the sign of the bigger number. 17 is bigger than 5, so I keep the positive. But I need to check my work. If I put in 12 for x, I get 12 minus 17 equals negative 5. Well, if I do 12 minus 17, I see that I get negative 5 equals negative 5, so it's true, and x equals 12. All right. Drawing my line. Now I have x plus 3. Since this is a plus, I want to do the opposite. On the last two I've been adding, but that's because plus is the opposite of minus. So now minus is the opposite of plus, so I'm going to subtract 3 from both sides. And I get x equals 14 minus 3 is 11. Checking my work, I would get 11 plus 3 equals 14. Is this a true statement? Sure is. 14 is equal to 14, which means that this is correct. Drawing my line. Opposite of plus is minus. So I subtract 13 from both sides because what I do to one side, I do to the other. These cancel, and I just have x equals 7 minus 13. Since the signs are different, 7 is positive and the 13 is negative, I'm going to subtract them. 13 minus 7 gives me 6. And then I keep the sign of the bigger number. 13 is bigger than 7, so I'm going to use that minus sign. And it's going to give me x equals negative 6. Final step is to check our work. And I'd get negative 6 plus 13 equals 7. You can also use your calculator to check your work. And yeah, so we get x equals negative 6. So now I have a few problems for you to try on your own in your notes. Go ahead and pause the video, try these problems, and then resume the video and see how you did. Answers and go over them together. For this first one, we have x minus 14 equals 2. Since the sign was a minus, I added 14 to both sides. And when I did that, I got x equals 16. If I check my work, I get 16 minus 14 equals 2. This would give me 2 equals 2, so that is correct. Next, I'd have 18 plus 23 equals 41. If I add these together, I get 41 equals 41, which is true. So x equals 18 is my final answer. Then over here, these two looked a little different because the x did not come first. X doesn't have to come first. And this plus right here does not determine what should happen. So if you subtracted 6, that's a problem, because we need to look at the sign that's in front of 6. Since the sign in front of 6 is a negative, we need to do the opposite, which is positive, and add 6 to both sides. So if we get negative 6 plus negative 9, let's check and see if we get the right answer. Negative 6 minus 9 equals negative 15. This would give me negative 15 equals negative 15. So that means that this is our correct final answer. And then final step, or final problem, excuse me. Since it's a positive 42, I subtracted 42 from both sides, and that gave me 36. Just to double check, I have 42 plus 36 equals 78. When I add those, I do get 78. So since those match up, this is my final answer. So this is an introduction to solving one-step equations. There's only one step. We're either adding or subtracting something. And we're going to keep building on this. So if you have any questions or if there's something that needs clarification, please let me know. This isn't going away because, like I said, we'll continue to build on this. So ask all your questions and let me know how I can help you.